Dear aspirants, welcome to my channel. This is an Diploma C25 Mechanical Engineering. Semester is third semester. The model question paper. Subject name is Mechanics of Materials. Subject code is 25ME31I. Already I have explained MCQs and fill in the blanks questions, and this is the 2 marks questions you are going to learn in this video. This is the 2 marks question. So define concurrent forces. So what do you mean by concurrent forces? Concurrent forces nothing but two or more forces, those whose line of action intersecting at a common point, that we call it as an concurrent forces. This is the point intersecting with a common point. All the forces which is intersecting with a one point, that we call it as a concurrent forces. So coming to an example, the force acting at a pin joint of a truss are concurrent forces. There's a truss you have, you can see the truss, everybody knows the truss, it will be look like this. Okay, it is a joining with a common point, that we call it as an concurrent force. Next is state the Hooke's law. So if you see the Hooke's law statement, within elastic limit of the material, stress is directly proportional to strain. You can write this: stress is directly proportional to strain. After the, you can stress is equal to E into strain. So here what is E is an Young's modulus or modulus of elasticity. Okay. Next is the write the relationship between E, G, K. Usual notations. Coming to that relationship. So this is the relationship, this is the formula. E is equal to 9 kg divided by 3 k plus g. So here E is Young's modulus or modulus of elasticity. G nothing but modulus of rigidity or shear modulus. K nothing but bulk modulus. So this is the relationship. That is, in material will be an homogeneous. It is valid for homogeneous, isotropic and linear elastic materials. Okay. This is the relation between E, G, K. Name any two types of load acting on a beam. Okay. So you can see point load, nothing but concentrated load, uniformly distributed, that we are call it as an UDL in a short forms, uniformly varied load, that we call it as an UL, or and applied moment or couple. These are the force acting on a beam. Next is what is a bending moment diagram or BMD. It is a bending moment is a graphical representation of variation of bending moment along the length of the beam. Okay, if the magnitude and the nature nothing but if it is sagging, it is sagging the bending moment at the different section and different beams. So bending moment nothing but it is a graphical representation of various bending moment of a in a length of the beam. Next, write the bending equation with the usual notation. This is the bending equation: M by I is equal to sigma by Y, E by R. And here where M is the bending moment, I is the moment of inertia of the cross section, sigma, that is sigma we can write like bending stress, and Y nothing but distance of outer fiber from neutral axis, E is Young's modulus, R will be the radius of curvature. Next will be a state the parallel axis theorem. So coming to the statement, the moment of inertia of the plane area about any axis equal to the sum of the moment of inertia about the parallel axis passing through a centroid and the product of area and square of the distance between two axes. Now you can see the statement. You can see the formula. It is I nothing but moment of inertia. I is equal to Ig plus A into h square. Should be the depending upon area and height distance of an two axis. Here I nothing but moment of inertia about any axis. Ig is a moment of inertia about centroidal axis. A nothing but area of the cross section. H nothing but distance between the two parallel axes. Next, coming to write any two importance moment of inertia in the design. What is the importance of moment of inertia in the designing? First, it should be determine the resistance of beam or structural member against the bending, and it helps to designing the safe and strong structure by selecting a suitable cross section shape withstand the load. Okay, if the content is useful, please subscribe my channel, share and support. Thank you. I'm going to upload 3 marks question, 5 marks question and 10 marks questions videos. Thank you.